Hello students, this is Anjana from Computer Science Department. In this class we are going to discuss about the sum of the products and product of sums simplification. Now let's get into our topic. These are the contents related to our topic. Sum of the products, products of sums, standard SOP and POF forms, how we are going to convert SOP to standard SOP, and how we are going to convert the POS to standard POS forms, and about the min terms and what are the min terms and what are the max terms. See, this is something related to the sum of the product. See, the sum of the product is a form of the method of simplifying the Boolean expressions of the logic gates. In the previous class, we have already discussed that what are the Boolean expressions and logic gates there. Then how we are going to convert the logic gates by using the Boolean expression. Okay. Here in this concept, the sum of the products, it is a form that how we are going to simplify the Boolean expressions by using the logic gates. Okay. See, for example, if it is the expression like ABC plus A dash BC, here in ABC the operation that we are going to perform is a multiplication operation, and ABC plus A dash BC means that is a sum of the products, that is we are going to sum the product of the two terms. Okay. For example, here this is the following is the expression that we are going to use here. See, f is the function, ABC is the variables that we are going to use in this expression. Here in this expression, if first expression is ABC means we are going to perform the multiplication operation in between the variables A, B and C, and next one A dash B C dash, that is we are going to perform the multiplication operation in between A dash B and C dash. So in between these two things, that is in between these two expressions A B C and A dash B C, this is the multiplication of these three variables. This is the multiplication of these three variables. In between these two expressions we are going to perform the sum operation. So we can say this is an example for the sum of the product. Okay. Here the sum and the product is derived from the symbolic representations. Here it basically it is derived from some symbolic representations like and or functions. For or we are going to perform the addition operation, and for and we are going to perform the multiplication operation. That is we are also having some AND gates and OR gates. If you are using AND gate means we are going to perform the multiplication operation. If it is OR gate means if in that logical figure, if you find any AND gate in between two variables, then we are going to perform the multiplication operation in between those two variables. But if you have observed any OR gate in between these two variables, then we can say that you are going to perform the addition operation in between those two variables. Okay. See, that is the product of, then let us see what is the product of sum when two or more, that is if you are having some two or if you are, it should be two or more variables. Why? Because we have to perform any operation. If you are going to perform any operation on a particular variables, it must and should we need to have a two variables. See, in this thing, in the product of sums, we are going to perform the multiplication operation in between the two sum terms. Okay. See, when two or more sum terms are multiplied by a boolean or operation, then the sum of the terms are defined by using the OR operation, and the product of the term is defined by using the AND operation. Sum of the terms means what? We are going to perform the sum operation in between those two expressions, and the product of sum means once we are going to product that is we are going to perform the multiplication operation in between this sum of the variables. But whenever you are going to perform these two things, whatever you have to keep it on mind means we should have at least more than one variable. Why? Because in between, if we have only more than one variable, then only we can easily perform the addition or multiplication operations. But the sum of the terms where we are going to define is when two or more sum of the terms are multiplied then by a boolean or or operation, then the sum of the terms are defined by using the and or operation. Here it is defined by using the AND operation. Here this is the expression here. If you have observed this expression, this is f of a comma b comma c, that is equal to a dash plus b into b plus c dash, that is sum. This is sum terms, and for this sum terms we are going to perform the product operation. So we can say it as a product of sums. See, then what are the standard SOP and POS forms? The canonical forms are the special cases of the standard SOP and POS forms. See, here we can say these are also known as the standard SOP and POS forms. That is for to perform the sum of the products and product of sums, we should follow some forms. That is it must be a canonical form or the special cases of the SOP and POF form. Suppose if you are going to apply a product of sum of products operation, the basic thing you have to keep it on mind is it is more than one variable, and in order to perform the sum of the products, each and every, first of all, each and variable should be multiplied in the first expression, and in the next expression also each and every variable should be multiplied. Further, for those two expressions we are going to perform the sum operation. Then these are also known as the standard SOP or POF forms. We can say simply we can say this one as a standard SOP or POS forms. Okay, then what is the basic thing that we have to keep it on mind? We have already said whenever you are going to perform the standard operation, you have to follow some rules. Then let us see what are those forms. See, if it is a canonical form, in SOP or POF forms, all the individual terms do not involve all literals. Each and every variable should not involve some literal. See, in one expression, if it is having only two variables, in the next expression it may have more than two variables. That may not be a rule that it should have only two variables in these two expressions. But that might not be a rule, but it not compulsory that the next expression has used more than two variables, so that we in the first expression also we have to use that same variables. That is not compulsory, but the basic thing that we have to keep in mind is it should be more than one expression. Why? Because when all if it is having more than one expression, it's a variable itself, then only we are going to perform operation on that. Suppose in SOP and POF forms, all the individual terms do not involve all literals, then if the each term in SOP and POF contains all literals, then the expression is known as the standard canonical form. Okay, see, then what is the canonical form? Here here the each individual term in the product of sums, we can say it as a max term. Okay, whatever the individual term, whatever the individual terms in the POS form, we can say it as a max term. Whatever the individual term in the product of sum of the products, we can say it as a min term. Okay, the individual term in the product of sums is, we can say it as a max term. The individual term in the sum of products, we can say it as a min term. Okay, in min term we look for the functions, whereas where the output results should be 1, and while in the max term we look for the function where the output is 0. But when we perform the sum of the min terms, and we can say it also known as the sum of the products, when we perform the product of max terms, we can say it as the product of sums. See, these are the canonical form for the each individual term for the each individual variable in the sum of the products and product of sums here. But if it is a each individual term in the product of sums, but when we look into the picture, the each in min term we look for the functions, where the output result is 1. But while the max term, we look for the function where the output result should be 0. But here we perform the sum of the min terms, and so we can say it also known as sum of the products. Sum of the products is also known as sum of the min terms, and the sum of the max terms is also product of the max term is also known as the product of sums. Okay. Here, but each individual term in the production of sums is also known as a max term, and each individual term in the sum of products is also called as min term. In min term, we look for the functions where the output result is 1, while in the max term, we look for the function where the output result is 0, but we perform the sum of the min terms, and we can say it also known as the sum of the products, and we perform the product of sums, we can also known as product of sums. Okay. See then how we are going to convert the sum of the products to the standard SOP form. Okay. Here, if it is a finding some missing literal in each product, then each product term having the missing literals with the terms formed by the o-ring literal and its complement. But in the step 3, it expands the term by applying the distributive law and reorder the literals. Then we have to reduce the repeated product terms, because we are going to perform some distributor law on that. Why? Because if it is a repeated thing, then definitely it may cause some it may cause some disturbance. Just for that we have to take something into the picture. Then just like that we have to keep it on the mind. Then we simply find the missing literal in the each product. Then each product term having some missing literals with the terms by wording literal and its complement. But if it is if it expands the term by applying the distributive law and reorder the literals, then we should reduce the repeated product, because it should be a plus a is equal to a. But if it is a finding the missing literal in the each product, but it may be formed by the o-ring literal and it's the complement. See, if you have observed this example, this is a Boolean expression. That is, here we have taken the function a comma b comma c. Why we have taken that function a comma b comma c is, we are having 3 variables, so we are using the functions a comma, we are using the variables a comma b comma c. Here it is the product sum of products, that is AB, BC, AC is products, and we are going to perform the sum operation for that. So it is a sum of products. Okay, clear. Then first of all you have to find in the missing literals in the each product. Here what is the letter missing here? C. Here what is the letter missing here? A. And here what is the letter missing? B. So first of all we already find out this missing letter, such that we can simply we can write like that. If it is c plus c dash, c plus c dash means the value becomes 1. So we can write like this: ab into c plus c dash, bc into a plus a dash, ac into b plus b dash. Simply we can write like that. See, then it expands the term and reorder the literal. See, if it is this expression, how we are going to perform this ABC, ABC dash plus BCA plus BCA dash, ACB plus ACB dash. Just like that, we are going to perform. See, we have next we have to omit the repeated here. What are the repeated things here? ABC, ABC. So we have omitted the one repeated term. Then the expression will become ABC, ABC dash, A dash BC plus A B dash C. This is the expression that we have converted into the converted this product of sums into the standard sum of products. Okay, this is how we are going to convert the sum of products to the standard sum of product forms. See here in this step 3 we have expanded this one. In the step 3 we have expanded that one, and we have reordered the literals. After that we have checked whether what is the repeated product terms, and after checking that We have taken out the repeated thing, and finally we wrote the expression like this. See, here in this how we are going to convert the product of sums to the standard product of sums form. See, first of all, in the step 1 we have to find out the missing literal in the each sum term. In the each sum term, what we have to find out? We have to find out the missing sum term in the each literal. Next one, or each sum term having the missing literals with the terms formed by and literal and its complement. Okay, see, uh, in the step 3 we are going to expand that expression by applying the distributive law and reorder the literals. That is the thing that we are going to perform. Next one, step 4, we are going to reduce the repeated product of sums because a plus a is equal to a based upon the theorem 1a. This is how we are going to convert the product of sums to the standard product of sums form. See, these are the steps that we are going to follow. First step is we have to find the missing literal in the each term, if any. Next one is the or the each sum term having the missing literals with the terms from the and in the literal and its complement. Next one, expands the term by applying the distributive law, and next we are going to reorder the details. Next one, reduce the repeated product of sums because the law will become a plus a is equal to a. So just like that we are going to perform these 4 steps first. After applying these 4 steps itself, we are going to convert the POS to the standard POS form. See, this is the example here. First of all, this is the expression a plus b into b plus c into a plus c. Here, what are the missing literals here? Here the c is missing, here a is missing, and next one here is b is missing. How we are going to perform? Plus c into c dash plus a into, here the missing literal is c, so we have applied the this formula here by using the distributive law. Plus c into c dash becomes c into c dash is 0, so a plus b plus 0 becomes a plus b. Okay, a into a dash also becomes 0. Just like that we have performed the operation here. See, if you observe the step 1, what happened here? We have first step, we have to find out the missing literals in the each sum, and next here we are going to find the missing literals in the each sum term, and next we are going to find out the sum the term with that missing literal. Okay, here the missing literal is c, here the missing literal is a, here the missing literal is b. Just like that, after checking that one, we are going to add that a plus b to c plus c dash, b plus c to a dash, a plus c to b dash. Just like that we did. Okay, next see, we how we have expanded this expression is this one expanded the term, and we are going to reorder the letter. How we are going to expand and how we are going to reorder the literals? Just see here the expression a plus b plus c dash plus b plus c plus a dash plus a plus c plus bb dash. See, here a plus b plus c, we have expanded this expression. A plus B plus C plus A plus B plus C dash into A plus B plus C into A dash plus B plus C into A plus B plus C into A plus B dash plus C. See, this is the final output expression that we will get here. And next, what is the expression that we'll get? Let us see here. What is the repeated term? Please check once. What are the repeated term that we'll get here? A plus B plus C, A plus B plus C dash, A plus B plus C, A dash, A plus B plus C, A plus B plus C. This is the repeated term that we will get here. So simply we are going to omit these two expressions, these two Boolean expressions. So after omitting this Boolean expression, we'll get that. What are the expression that we'll get? That is the final output that we'll get. So now let us see about the min terms. Min terms are the end terms with every variable present. What is the variable present that we'll get? With every variable present in either true or completed form. See, if it is a true or completed form, then we can simply given that each binary variable may appear. It may appear normal or in a complemented way. There are 2 power n variables there. Then the two variables x and y will produce. It will become, suppose it is if it is 2, then the most possible combinations are 2 power 2. Okay, the basic formula for this one is 2 power n. Suppose if it is a 2 variable function, then simply we can write like 2 power 2. So it will become like 2 power 2 means it will become 4. So the maximum number of possible combination that we'll get is xy, x into y dash. That is here xy means both are normal. X into y dash means x is normal and y is complemented. X dash y means x is complemented and y is normal. And x dash y dash means here both the variables are complemented. Okay, that is nothing should be done, will be done if both are both are complemented. So these are the min terms. So here what are the whenever you are going to perform end operation, we can say it as a min term. Okay, here xy is a both normal form and xy dash is a x and normal and y is a completed form. And next one is x dash y, that is x is complemented and y is normal. And next one is x dash y dash means we have already know that these both are complemented. Suppose if it is a min term, how we can say it is a min term? These are the end terms with every variable present in either true or complemented form. Suppose given that each binary variable may appear normal or comprehended, then there are 2 power n into m variables that we are going to present here. Suppose the two variables x and y produce the output will become 2 into 2, that is 4. The number of possible combinations also will get is also 4. So xy, we here the both are normal. X into y dash, that is x normal and y is complemented. X dash into y, that is x is complemented and y is normal. And next one x dash into y dash, that is both x and y are complemented here. So here we have already observed that 2 power n, then the maximum number of possible combination that we are going to get is 4. Okay, go for the next slide. Now see what are the max terms here. Max terms are the odd terms with every variable in true or the complemented form, whether it is in the true form or the complemented form. Here these are the max terms that with each and every variable in the true or complemented form. Suppose if it is a max term, like we have already said in the previous example, if it is the sum of the products, the number of most number of possible combinations is 2 power n. 2 power n means 2 power, here the variables that we are going to use is only two variables. So I based upon that I kept two variables here, that is two expressions here. Based upon that expression itself, she has to recognize, she is he is saying, but like that only we are going to produce that. So now let us look into the picture. So these are the max terms that we are going to, max terms or the odd terms with every variable in the true or the completed form. But if we given that each binary variable may appear or normal, suppose if it is a complemented, there are 2 power n max terms for the n variables. See, these are the two variables x and y, it will produce 2 by 2. Here also we are having the maximum number of possible combinations is 4, that is x plus y. Here the both are normal. Next one is x plus y dash, that is x normal and y is complemented. Next one x dash plus y, x complemented and y normal. Next one is x dash plus y dash. Here both things are complemented. Okay. See, this is the, if it is three variables, that is if it is three variables, the most number of possible outcomes will be 8. Here 0, if a value is 0, b value is 0, c value is 0. Here this is the first case. If a value is 0, b value is 0, c value 1, this is second case. A value is 0, b value 1, c value 0, this is third case. A value 0, b, c values both are 1. Here this is fourth case. Here the first a value is 1, b value is 0, 1. This is sixth case, and next one is 1, 1 and 0. Next one is 3 1. This is the basic thing that we have to keep it on mind. Next one is after that, if it is a dash, b dash, c dash, we can say this one as M not. We can say this one as min terms. We can say whenever we are going to perform the multiplication operation, we can say that one as a min term. If it is sum operation, we can say it as a max term. Okay. Based upon that, simply we can write a dash, b dash, c dash, that is M not. Next one a dash, b dash, that c, that one. Based upon that, we are going to write the min terms and the max terms. See, if it is a min term, if you are having the min term in M0, M2, M3 and M7, based upon that she wrote something like that. So here the variables is 0, 2, 3, 7. That is, if we have observed sigma, then obviously it will become the sum operation. Okay, these are the sum of the min terms, examples of the sum of the min terms. Next one, if it is like this, then these are the examples of the for sigma. If it is sum operation, we are going to use the symbol sigma. If it is a product operation, we are going to use the symbol pi. Okay, these are the two variables that we are going to use here. So this is the basic example for the min terms and max terms. So up to here we have discussed about sum of products and product of sums concept. In the next class we will continue this chapter. Okay, thank you.